Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. E2 elimination of HBr requires removal of a beta hydrogen by a base. The ease of elimination depends on the acidity of the beta hydrogen, i.e., how readily it can be removed, and the stability of the transition state. Electron withdrawing groups, EWGs, on the carbon bearing the beta hydrogen increase the acidity of that hydrogen, making it easier to remove and thus facilitating elimination. Conversely, electron-donating groups or the absence of activating groups make the beta hydrogen less acidic and less susceptible to elimination. Reasoning. Option A Br CH2 CH2 NO2. The nitro group, NO2, is a very strong EWG. It strongly activates the beta hydrogens on the CH2 adjacent to number 2 toward removal by a base, making this compound highly susceptible to elimination. Option B Br CH2 CH2 CH3. The propyl group, CH3, is electron-donating alkyl group. There is no EWG to activate the beta hydrogens. The beta hydrogens are least acidic among all four options, making this compound least susceptible to elimination of HBr. Option C Br CH2 CH2 CN. The cyano group -CN is a strong EWG, activating beta hydrogens toward elimination, making it more susceptible than B. Option D Br CH2 CH2 Co2 The ester group, Co2 is a moderate EWG, also activating beta hydrogens toward elimination, making it more susceptible than B. Among all options, only B has an electron-donating alkyl substituent, which does not activate the beta hydrogens. All other options have EWGs that facilitate base-mediated elimination. Therefore, B Br CH2 CH2 CH3 is least susceptible to elimination of hydrogen bromide. Therefore, the correct answer is B. Therefore, the correct answer is option B.